So welcome everyone to Strait Science. We're an evening science presentation series put on by UAF Northwest Campus here in Nome and also UAF Alaska Sea Grant. And tonight you're in the home office. So tonight's speaker, it's a bit of a 1-2 punch. This is the number 2 punch. We heard from Lyle Britt last week regarding the bottom trawl survey in the northern Bering Sea, and he also gave kind of the whole Bering Sea. It was very interesting. And Jim Murphy is going to follow this up with the results from the surface trawl survey. So this is going to be very interesting tonight, and we really welcome Jim. Jim Murphy is a research biologist with NOAA Fisheries. He's in the Alaska Fisheries Science Center in the Off Bay Labs in Juneau. So he's coming to, whereas Lyle was coming from Seattle, Jim Murphy's going to be talking to us from in-state in Juneau, and he is with the Salmon, Ocean Ecology, and Bycatch Analysis Group. So we are really looking forward to Jim. He's actually been working in the region for 25 years, I think, and we're so excited that this is his first time with Strait Science, and so we can't wait to hear what you have to tell us, Jim. Take it away. Welcome.
Okay, well, thank you, Gay. You can hear me okay?
We can hear you okay. Oh,
okay.
And I guess we never resolved it, but I guess, did you want questions at the end, or do you want people to jump in?
I might stop halfway through just to answer a few questions, but maybe try to, if there might be a few questions towards the end. I suspect some of the slides towards the end may generate more questions.
Okay, and I'll be monitoring the chat for all of you. And for our phone caller who has no ability to chat, you will have to speak up. You can either do that, I guess, during the presentation or hold your thoughts until the end. With that, thank you so much, Jim Murphy. Take it away.
Okay, well, thank you, Gay. And thanks to everyone for joining in on holiday. So I'll be presenting some of the initial results from the Northern Bering Sea Surface Trawl and Ecosystem Survey. So we'll have more information that will come available over this next year as some of the laboratory analysis are completed. These surveys have been conducted in the Northern Bering Sea for the last 20 years or so. At least we started them in 2002 as part of the Bering Aleutian Salmon International Survey. And they've continued as part of a number of different research initiatives over time. And most recently, they've been conducted as the Northern Bering Sea Surface Trawl and Ecosystem Survey. There's many folks that have contributed to the survey over time, and Fish and Game has been a key partner on the survey, and scientists like Sabrina Garcia and Katie Howard have helped us address the salmon concerns in the regions. And we've also had scientists from U.S. Fish and Wildlife Service, Kathy Kulitz and Liz Lebunsky, who've been helping us with the seabirds during the survey. And we've also had scientists from PMEL who've helped us with the oceanographic data. So we chartered the commercial fishing vessel, the Northwest Explorer, to conduct the survey in 2002. The survey occurred primarily during the month of September, and there were quite a number of different COVID-19 protocols that went into planning for the survey in 2021. The timing of the survey was established at the beginning to match the timing of marine entry and dispersal of juvenile salmon from the estuarine habitats. And we've attempted to keep the timing of the survey as consistent as possible over time. The figure here on the right shows the stations that we sampled in 2021. And so this is about 46 primary stations. And it's similar to the station locations we've used in recent years. However, there have been some changes in station locations on the survey with different objectives by the different research projects, as well as the availability of ship time. And let's see here, in 2021, we had a number of different survey operations that occurred at each of the stations. Included C2D profiles, and a C2D is an instrument that we use to collect information on the temperature and the salinity and other characteristics of the water column. Collected water for nutrients, environmental DNA, and also phytoplankton, and that includes some of the harmful algal bloom species. Bongo nets were used to collect zooplankton, Those are small invertebrate prey species in the marine food web. And benthic grabs were used to collect sediments. And we had beam trawls that were used to collect bottom-dwelling fish, crab, and invertebrates. And we used surface trawls to collect information on pelagic fish and invertebrates. Pelagic fish are species that occur within the middle and the upper water column, such as herring and salmon. And we also monitored the distribution and abundance of marine birds during the survey. So although water temperatures cooled from the record warm temperatures we saw in 2019, the surface temperatures were slightly above average in 2021. That's shown in the figure there on the left. The coolest surface temperatures were just north of St. Lawrence Island. That's the figure in the center. And the coolest bottom temperatures were just south of St. Lawrence Island. Excuse me, that's the figure on the right. Temperatures on the bottom have a much greater range than the temperatures at the surface in the northern Bering Sea. Surface temperatures range from approximately 7 to 11 degrees Celsius, whereas the bottom temperatures range from sub-zero temperatures to 11 degrees. Bongo nets are these fine mesh nets that we tow through the water to collect zooplankton and larval fish. Zooplankton are these small invertebrate prey species that are a key part of the marine food web and are important food for many of the fish and seabird species in all marine ecosystems. Zooplankton abundance is probably measured with detailed laboratory-based methods, but we also provide coarse measurements of zooplankton abundance on board the vessel. And the laboratory estimates have not yet been completed, but I'll show the results of some of the onboard estimates of zooplankton.
Jim, we got a question in the chat from one of the viewers. Can you explain eDNA and what you were looking for when you collected your samples?
Oh, yeah. Yeah. So eDNA, or environmental DNA, is all fish and marine life sheds DNA. And so by collecting DNA in the water, you can get an idea of what species are living in that location. And to some degree, you can get some idea of what the most abundant species are just based on the DNA that's in the water. And so when you're collecting DNA in the water, it's called environmental DNA. Does that work? Does that help?
Yes.
Okay. So the first group I'm going to talk about are small cocoapods. These are a very small species group of zooplankton. They're less than 2 millimeters in length, so they're very, very small. They're very abundant in most marine ecosystems, and in the northern Bering Sea, they have numbers in the range of 1,000 to 10,000 individuals per square meter. They're present throughout the northern Bering Sea, and their abundance has been relatively stable over time. So the figure on the right shows their abundance over time. And the figure also on the right shows the estimate for 2021. So as you can see, the abundance of these small zooplankton were very similar to what we've seen in previous years. And Dave Kimmel from the Alaska Fisheries Science Center and Alexia Pinchuk from the University of Alaska helped put together the zooplankton data for this year. Large copepod species, essentially greater than 2 millimeters, are less abundant, but they're an important energy-rich food source. Their abundance has been quite variable over time in the northern Bering Sea. And the abundance in 2021 was a bit higher than what we've seen in the more recent low ice years. And the figure on the left shows their distribution, and they reached their highest densities in the areas in the Bering Strait region. Now, the fat or lipid content of zooplankton is a key part of their nutritional value. The fat content of copepods were typically in the range of 10 to 15% of their body weight. So that's a very rich, high fat content. Their highest values of fat were found further offshore and typically in the southern portions of the survey area. And that's the figure on the left. The figure on the right is the fat content of euphausids. So euphausids are often referred to as krill. They're another important species of zooplankton. And their lipid contents were lower than cocoapods, typically in the range between 2 to 5% of their body weight. In general, their fat content is fairly similar across the survey, with perhaps slightly higher values at stations just northeast of St. Lawrence Island. So Dan Cooper came on the survey this year and helped us set up beam trawling. And this was in part to help some of the research by Louise Kochman on the essential habitat of juvenile crab. The beam trawl gear we used on the survey is a very small bottom trawl. It's approximately 3 meters or 9 feet wide. And it's designed to catch the juvenile stages of bottom dwelling fish and invertebrate species. These two figures here show the distribution of juvenile yellowfin sole on the left and juvenile Kinesides crab. So Kinesides crab are a combination of snow crab and tana crab. The width or the carapace width of these juvenile crab are less than 15 millimeters, so less than the width of your index finger roughly. And we're not able to distinguish between these species at this life stage. The small stages of crab sampled in the beam trawl survey are rarely captured in the bottom trawl surveys that Lyle presented last week. And so these data that we have on crab really complement the crab assessment data that are collected on the bottom trawl surveys. Juvenile yellowfin sole were the most abundant species of fish captured in the beam trawl gear, and yellowfin sole were primarily found in the nearshore stations. Juvenile Kinesides crab occurred at more intermediate depths in the survey, and they were present in both the southern and northern portions of the survey. Shrimp were the most abundant species of fish and invertebrates that were captured in the beam trawls. And two common species of shrimp were ridged crangon shrimp and northern shrimp. And northern shrimp are also known as pink shrimp. Their distribution in the survey is shown here in these two figures. Now, shrimp were only identified as species during the second half of the survey, and so we only have these species-specific distributions from the northern section of the survey, since we sampled the surveys from south to north. Both species were present throughout the survey area, but they reached their highest densities in North Sound. So I guess I could pause here if anybody has questions on that data. Otherwise, I will move on and talk about the surface trawl gear. Surface trawl data.
All right. Any questions for Jim Murphy on what we've heard so far? All right, Jim. Okay.
Good. Well, the trawl gear we use, the surface trawl gear we use is our large midwater rope trawls, and they sample the upper 20 meters, so upper 60 feet or so of the water column. This trawl gear samples a larger area than the area that's typically sampled by the bottom trawl gear that Lyle presented last week. And this is mainly because the density of fish in the water column is lower than the density of fish in the bottom. So it requires larger gear to sample these pelagic fish species. Again, the pelagic fish are fish that live in the water column and includes species like salmon and herring. Juvenile Chinook have been an important part of the survey, and the research on Chinook is focused on Yukon River Chinook salmon, since they count for about 80% of the juveniles in the northern Bering Sea. We know that Yukon River Chinook salmon are important to subsistence fisheries within Alaska and the Yukon Territory. They're also important to international treaty negotiations between US and Canada in the Yukon River, and they're important to bycatch in the Bering Sea pollock fishery. Juvenile Chinook salmon were found primarily in the nearshore stations of the survey, and this is a bit atypical for Chinook, as they tend to be more broadly distributed through the survey area. The figure on the right shows how their abundance has changed over time, and this includes the abundance estimate for the 2021 survey. Juvenile abundance was below average in 2021, and has been below average since 2017. We use genetic stock identification methods to estimate the abundance and forecast returns of individual stock groups of Chinook salmon. The two figures on the top are for the Canadian origin stock group of Chinook salmon from the Yukon River, and this is the largest stock group of Yukon Chinook salmon. And the figures on the bottom are for all Yukon River salmon stocks. And we haven't completed the stock composition estimates from the 2021 survey, and so these figures haven't been updated from the results of this year's survey. However, these stock-specific abundance estimates follow the overall pattern that we see in their abundance in North Bering Sea, and so we're expecting these stock-specific abundance estimates to be below average as well in 2021. The two figures on the right, they show the relationship between juvenile and adult abundance, and they both identify that the juvenile abundance provides a reasonably good indicator of what the adult returns will be to the future. And these are the two models that we use to forecast runs of Chinook salmon to the Yukon River. Juvenile chum salmon are also only present in these nearshore stations, and this is even more atypical for chum salmon, as they tend to be much more broadly distributed than Chinook salmon. So Sabrina Garcia has used stock mixtures of chum salmon to estimate an abundance index for fall chum salmon from the Yukon River, and that's shown here on the right. The index has been above average since 2018, and the two highest abundance indices have been in 2019 and 2021. The index for 2021 is a preliminary estimate, and it's based on the average stock proportions. And this estimate will be updated once we've completed the genetic analysis of chum salmon. Juvenile chum salmon returned to spawn as adults after spending typically 3 to 4 years in the ocean. This figure here shows the relationship between juvenile and adult abundance, similar to the other models that I showed for Chinook salmon. And the labels here on this figure identify the year that juveniles were sampled in the Northern Bering Sea. Overall, higher numbers of juveniles in the North Bering Sea contributes to higher numbers of adults returning to the Yukon River. However, the relationship for chum salmon tends to be more variable than what we've seen for Chinook. And I've highlighted the data point here from 2016, as we expected to see more adults returning to the Yukon River based on their juvenile abundance in 2016. And we believe that this is indicating that chum salmon are experiencing higher mortality during their later marine stages than what we've seen in the past. The model is still in development, but it's helping to provide a framework to improve our understanding of why we're seeing such a large decline of chum salmon in the Yukon River. Pink salmon were also found in the nearshore stations, and their abundance was particularly low in 2021. This abundance index constructed by Ed Farley is significantly related to adult returns to the Yukon River and Norton Sound. So for pink salmon, since there's very little genetic differentiation of pink salmon, we combine Yukon River and Norton Sound stocks in the Northern Bering Sea. But with this model, we're expecting to see low numbers of pink salmon returning to the region in 2022. The abundance index for coho is still very much a work in progress. And we're hopefully we can separate out Norton Sound and Yukon stocks. And if we can, this will provide a much clearer picture of their status in the North Bering Sea. However, our catches of coho salmon were quite high in 2021, and their biomass index, which is shown here on the right, was close to the highest that we've seen in the history of our sampling in the Northern Bering Sea. And hopefully this means that coho runs will be much better in next year. Oh, here we go. My computer's taking a little bit of a break there. So we catch many different species of fish in the surface trawl gear. A species many folks are probably familiar with is saffron cod. It's also referred to as tom tomcod, excuse me. Our catch of saffron cod in 2021 was particularly low, with only a few saffron cod near Norton Sound in the Bering Strait. These figures on the right, they're quite small, but the figure on the top shows our catch estimates of age 0 saffron cod. So these are young of the year saffron cod. And the figure on the lower right is our catch of older ages of saffron cod. So we've seen some fairly large numbers of young saffron cod in our survey, particularly during 2014 through 2017, but we've seen very few of these young saffron cod in our survey since 2018. We've also seen a decline in our catch of older ages of saffron cod. And although this could reflect possibly northward shifts in their distribution, similar to some of the distribution shifts that Lyle showed of cod, of Arctic cod and Pacific cod. However, saffron cod really are only present in these very shallow nearshore habitats, and so our catch of saffron cod in our survey may not be necessarily a very good index of their abundance. So unlike saffron cod, young of the year pollock and Pacific cod are found in the offshore stations of our survey. And samples from our survey are used to study the growth, the diet, and condition of these two species in the northern Bering Sea. One thing that I found particularly interesting this year was that there was a fairly large increase in the number of young Pacific cod or age 0 cod. Although we only caught a little over 250 age 0 cod, and that's a very tiny number compared to the number of pollock that we catch. Typically in past years, we would catch less than 20 age 0 Pacific cod. So this is a fairly large increase in the number of young cod in our survey than what we've seen in the past. Herring are the largest biomass of fish captured in the surface trawl gear, and herring were present throughout the survey with young herring, age 0 herring in the nearshore stations and older ages of herring found further offshore. The catch of all ages of herring was quite low in 2021, and their biomass index is shown here on the figure in the right, and it was the lowest that we've seen in the northern Bering Sea trawl surveys. Capelin were present in the Bering Strait region, and our catch of capelin tends to be very temperature dependent, and with higher catches of capelin in cold years. The abundance of capelin has been very low in recent low ice years, so it was good to at least see a few capelin in 2021, as they tend to be an important forage species in the northern Bering Sea. So by combining the catch of all these small fish species such as herring, capelin, juvenile salmon, and age 0 pollock, Ellen has constructed a forage fish index for the northern Bering Sea. And although we've seen low values of this index in previous years, the index reached its lowest value in 2021. And this was mainly due to the low abundance of herring. However, the lack of other forage species like capelin is also contributing to the low index in 2021. So Sabrina Garcia with the Department of Fish and Game has been tagging salmon sharks on the northern Bering Sea survey for the last couple of years. And this has helped improve our understanding of their migration. And you should definitely contact Sabrina if you have questions or any information on salmon sharks in the northern Bering Sea. Most of the information that we have on salmon shark migration is based on female sharks that have been tagged in the Gulf of Alaska. And salmon sharks in the Bering Sea are generally male sharks. And so the survey has provided a unique opportunity to add information on the migration behavior of male salmon sharks. Sharks are tagged with pop-up satellite archival tags, which transmit information on light, temperature, and depth to satellites. And they're also tagged with spot tags, which transmit actual location data to satellites when the sharks are at the surface. And that's quite frequently for salmon sharks. So the first shark that was tagged was in 2017, and that was tagged just east of Nunivak Island. You can see that, if you can see it, there's a purple star where it was tagged. And this shark left the Bering Sea shortly after tagging, and it migrated to the west coast of the US. And it spent most of the year, all the way through July, in the North Pacific and west coast of Alaska, or of the US, and returned again to the eastern Bering Sea the following August. The second shark was tagged in 2019, and this shark was tagged just south of St. Lawrence Island. And this shark had a very different pattern. It traveled south into the central North Pacific and remained there for most of the year as well, and returned to the eastern Bering Sea in June. And although these two sharks had very different migration patterns, they both returned to the eastern Bering Sea in the summer. And this may indicate that the eastern Bering Sea is an important summer habitat for male salmon sharks. Marine birds were also surveyed during the survey in 2021. And this is research that's led by Kathy Kulitz and Liz Zabunski at the Fish and Wildlife Service. And they've been monitoring seabirds for the last 8 years or so. And this has allowed us to establish a pretty good baseline for marine birds in this region. Short-tailed shearwaters were the most abundant species, and their abundance levels were fairly typical for this area and time of year. The figure on the right shows the distribution of shearwaters during the survey, and their abundance was higher in the offshore stations, and they were found throughout the survey area. The abundance of other marine birds were also fairly typical with what has been seen in previous years. And they also tend to be more abundant in the offshore stations. We had species like northern fulmar and murres that were the most common species of non-shearwater birds. Their abundance was also generally higher in the offshore stations and in the southern Bering Sea. Most of the auklets were present near the Bering Strait. That's the figure there on the right. But there also were a large number of auklets that were observed near Nunivak Island towards the southern end of the survey. During the survey, we observed 3 dead birds. There was 1 shearwater and 2 unidentified birds. And this was generally lower than what we've seen in previous years. But it's always a bit challenging to spot dead birds from a moving ship. So with that brief overview, I'd like to thank everyone who's helped us with these surveys over the years, and I'd be happy to take any questions or comments that you might have on the survey data, and just want to thank everyone who's contributed to the survey this year.
All right. Well, thank you, Jim. We will. You've given us quite a bit to think about there, and we appreciate that. So the first thing, there's 2 things. One is the audience give a little love before the questions. Give a little love to Jim Murphy in the chat, because it's not always easy, and he's on a holiday, no less, giving it to us here in Strait Science. You do have a bit in the chat, so I'm going to go with that. But the first priority are the callers. So while people are entering in their claps and thanks, you got some reactions there by people who know how to use Zoom very well. Any of the callers on the line, do you have any questions? Priority goes to callers. All right. Well, speak up, callers. It's not easy. So you do have several questions in the chat, and then why don't we hit those first and give people a chance to formulate their thoughts. I know I've got some questions, and I'm going to hold off till the end. So based on what you saw this year for juvenile Chinook salmon, do you think the run for the Yukon River will be below average? Now I see that Ed Farley has written in something, but it would be good to hear your thoughts on that. And the second is, any idea why the pink salmon abundance was so low this year? Because
Okay, well, go ahead.
we had people that came to the region, like Icicle Seafoods, and of course our own communities. Everybody was anticipating a big pink run, like we've been having in the past, stuff in the rivers actually, and it didn't come to pass. In fact, we had a kind of a rough year. But you better tackle the Chinook, juvenile Chinook one first.
Yeah, I can. We do have projections for at least the Yukon River Chinook salmon, and I didn't show those, but our projections is for a below average. It's probably going to be comparable, which was very low this year, but we're not expecting things to improve from what we saw in terms of run size for this year. If that is clear enough.
So it sounds like more of the same then?
More of the same that we saw, potentially even worse than what we saw this year.
Okay. Any idea why the pink salmon abundance was so low this year?
So this is where I'm presenting lots of people's data. And I'll let, I think Ed already responded to that. What did he say?
He does. He says, we don't know why, but I'm hoping maybe you had something else to add to that. Thank you, Ed, for adding your thoughts on that.
Yeah, so I think we're seeing, and I'm not sure, but there could be a connection to what we're seeing in chum salmon, where we saw the numbers of chum salmon come back to the river this year at a lower level than what we've seen in the past relative to the juvenile abundance. And so I think we are seeing that again in pink salmon, where the numbers that came back this year were lower than what we expected based on their juvenile abundance. And so it's possible that they're connected. And this may indicate that there could be higher mortality of pink salmon and chum salmon that's occurring offshore. If that is, I think that's, I haven't gone through that pink salmon as carefully as Ed, but pink salmon data as carefully as Ed, but I wouldn't be surprised if there could be similarities in those two species.
So we should expect more of the same for our fish in the Norton Sound, Bering Strait region?
I think so. I think Ed's forecast model for pink salmon next year is very low.
All right. Well, it's better to be informed than not. So I appreciate you delivering that news.
Yeah.
With that, you have, let's see. Thanks for a great talk, Jim. This is in the chat. Can you identify any drivers for the low forage fish numbers? Is it temperature? Is it zooplankton?
Yeah, that was unexpected. I think all of us were taken by surprise to see the low number of forage fish. I think capelin is pretty straightforward. I think because we're seeing such warm temperatures, that is I would say that's probably the main reason why we're not seeing many capelin in the survey. As far as the low numbers of herring, there's obviously one or two reasons why. One reason is that herring distribution have changed, and they're no longer present in this area, so that they could have moved further offshore, or move north or somewhere else, or it's possible that they are not surviving very well through these warm years. So the biomass index includes multiple ages of herring. So these are, anywhere between the age 0 stage on up to, I don't know, age 7, 8 years old. So typically we don't catch those really large herring like we have in the past. So I don't know what their ages. I imagine their age is around 5, 6, 7 years old. So it's any. So if it is survival, it would mean that it could be issues of survival that have occurred maybe even 3 or 4 years ago. But we can't really separate out the possibility that they could be in a different location than were our survey sampled. If that helps at all, I don't know.
Thank you for that. You also have another question from a viewer. Nice talk and thank you. Is there info being collected on the fitness of the forage fish, caloric content, and or stomach contents / fullness?
Yes, we have been collecting information on the energy density or the fat content of herring and capelin when they're there. So we do a nutritional assessments on most of the fish species that we catch on our survey. And we also examine the diet or the feeding habits of herring and capelin and all the fish species that we sample on the survey. So we have that data, but I didn't present that. And obviously in 2021, it'll be another year before those data are available.
All right,
But
well,
you can
we'll
ask
see
them
you.
to come present that results.
You bet. We want to hear what's happening. So that's
Mm-hmm.
great. Any other questions, phone callers and or attendees? This is your chance to ask up. Otherwise, I'm going to start asking my questions. All right, you've got another one in the chat. A lot of chat tonight. The salmon shark tracking data is really interesting too. Do you know what they are eating in the northern Bering Sea or simply living up to their name, salmon?
Well, I would say is if Sabrina is on the line, she could probably tackle that question. And if not, I can maybe take a stab at it, but I personally am not as familiar with the feeding habits of salmon shark.
Let me check if Sabrina's on the line. There's a way to do that. And
well,
it looks like she's not.
So one of the things that Sabrina had noted was that, in this case, the first salmon shark that came back to the eastern Bering Sea came back in August. So by August, a lot of the salmon have already returned to the rivers to spawn. So that would probably indicate that they're not necessarily following the salmon runs to this region. I think they do feed on salmon, but my guess is that they probably feed on species like herring, would be my guess, but I'm not familiar with their diets. That'd be my guess, because there's usually a lot of herring there.
Herring are good food, nice and fat. All right, hope that answers your question, Rob. Mm-hmm. And you have another one. Thanks, Jim. Early in the presentation, you reported on large copepod and krill abundances and noted that krill abundance is significantly lower than that of large copepods. Also, you noted that krill energy density of large copepods is less than krill. Do you have an idea of the general trend of krill abundance? Are they increasing under warming conditions? Are they decreasing?
Oh, well, good question, Jamal. So yes, there's some difficulties in measuring krill abundance, especially some of the larger sizes of krill are not really captured very well in the bongo nets that we have. They tend to avoid the net. So from the very beginning, we do have some difficulty measuring the abundance of krill. Relative to cobopods, we do a pretty good job. Our nets do a pretty good job with cobopods. They do, typically, I think it's the juvenile stages of euphausids that are caught in our bongo nets. The adult stages are not. Krill also have much lower energy than what you typically see in a copepod. We've seen of the cocoapods that we've captured in our trawl, in our bongo nets, excuse me, their abundance has been fairly variable over time, but we did see an increase in the number of krill that was in the survey this year. And so in general, it looked good. It looked like there were good numbers of krill, I guess I would say in general. There's other complications. We're basing this off of onboard estimates, and they also tend to underestimate their true abundance when you use laboratory-based estimates. So if you try to make some sort of correction for them, it could be some of the highest numbers of krill that we've seen since we started the survey.
So krill, by krill, you mean euphausids?
Yeah, krill, euphausid, excuse me. Euphausid abundance.
No, krill is good. I'm just clarifying for my purposes, my own purposes.
I'm using it interchangeably.
No, common names are great. I'm just asking to make sure that's what you're talking about.
Yep. So only because there's some complications with our abundance estimates of krill, I decided not to show that. But the data we do have seem to indicate that there are good numbers of krill or euphausids in the survey area.
All right, you're getting a lot of thank yous for sharing. Get back down. And herring are tasty. I agree with that. Yeah. So I guess if there's nothing from the callers, I'm going to ask a couple questions because I've been. So you had mentioned that the forage fish are down, and that's something that is a real interest because so many things in this region, in the Bering Strait region, are relying on those forage fish, the seabirds, the young juvenile seals, you know, so forth and so on. Is it because, I mean, we've become, our ecosystem has so much change upon it right now. We had those Pacific cod come up from the south. We had the pollock come up from the south. They seem to gobble up those things. We've got all kinds of swirl going on. We have stellar sea lions right now in number in the Bering Strait. High north, I mean, for us, they're up by Diomede right now. And until the ice scoots them out of here, we've had a lot of sea lion activity, a lot of humpback whale activity. Is there any consideration when you're going into your modeling about sort of the predator shift going on, and that we've become a little bit, perhaps if you're a small fatty forage fish, we've become a bit of a predator pit for more than normal, meaning all of a sudden there's so many things that have arrived that might eat you. And there's declines in other things that there's more pressure to turn to you as a small fatty fish swimming around out there. Is that taken into consideration, that sort of the predator pit that we may have become here?
Yeah, that's a good question. I think there's a larger ecosystem question that that we need to get a handle on. I don't know like how important herring are to the diets of sea lions, or I'm not as familiar with the herring are a really important part of their diet, or
humpback whales, herring, spotted seals, everybody in that.
So I think that's an area of concern, and I think I don't have any answers with that, but it's obviously understanding that top-down apex predator control on the ecosystem and how that affects lower trophic levels is a very important question. Just how those top-down controls, especially if you get kind of a reduction in production for a few years, that might be something as a downstream effect that could have resulted from poor survival of these forage fish 3-4 years ago. So you may not see that signal really manifest itself until several years into the future.
Well, thank you, because I was just sort of thinking, we've got sharks coming and wanting fish, and we've got everybody, and without the salmon, it just seems, and with all the different players that are now up here looking for food, somebody's getting hit harder than normal, I would imagine, by predation.
Yeah, yeah.
Anyway.
So the predators that are more dependent on salmon and things like that, what do they feed on when salmon decline? Those are prey switching, dynamics have become really important in these ecosystem processes. I agree.
You have another question in the chat, and that is, are there any plans to expand survey efforts in the northern Bering Sea with low Yukon salmon returns pointing to marine survival? And there's different times of year, different gear types, ?
Yeah, well, actually, and I don't know if I might pick on Ed for this question. He can talk a little bit about, we are planning a survey in the North Pacific across. This is going to sample across the entire North Pacific, and so these would be areas that chum, salmon rear, and pink salmon rear during the high seas stage. I don't know if Ed, if you want to say anything, but you can talk about that survey because that's an expansion. It's a different area. It's designed to really get a better handle on what's happening on salmon during their later marine stages.
Yeah, well, thank you, Jim.
Show yourself, Ed.
Okay, I'll show myself.
There you go.
I'll stop sharing my screen.
Okay.
So this winter, we have an International Year of the Salmon survey planned starting in February. It is going to cover the entire North Pacific, Gulf of Alaska, south of the Aleutian chain, all the way over into western North Pacific. We will have 4 research vessels at sea. Winter is a critical period for salmon, and we really believe that the chum salmon returns to the Yukon have been impacted at 2 critical life history stages. First, in 2016, we saw in the juvenile data that Jim just presented, we saw a real shift in the juvenile chum salmon diet. They went to start feeding on very poor prey items, and they came across late summer with lower fat reserves. And then they went from summer out into the Gulf of Alaska. That is where they overwinter. And in the Gulf, there was some changes there too, where we started to see yet another marine heat wave. And we think that this poor condition from early on, marine heat wave, competition at sea, likely gave them a double whammy, and why that we saw a lot of juvenile salmon in our survey, but the returns did not materialize based on the juvenile index. So this winter survey, we've had 2 of them in the Gulf of Alaska, but in a limited fashion in 2019 and 2020. And in 2019, we did catch Western Alaska chum salmon in the Gulf of Alaska during winter. So we're going to expand that coverage to cover the Gulf plus south of the Aleutian chain to get a better picture of that ecology or the conditions that these fish are entering in their first winter at sea. One of the things that, Jim mentioned that there might be some ties between pink and chum salmon, yet the juvenile chum or juvenile pink salmon index from 2019 really predicted a fairly good return in 2020. I know that there wasn't much of a 2021 return this year, but we didn't have a 2020 survey because of COVID. Now, what likely is happening here for pink salmon is it's probably freshwater to early marine. So if next year there's a very low return, which should be a fairly high return to your region, because even years generally have a higher return of pink salmon. This is what's concerning us with the juvenile index, that it was so low. We should have saw way more pink salmon out there this year. So again, that might mean a different period where constraints had impacted their survival. So this region is changing rapidly, as you know, you all that live there. It's changing rapidly. In 2016, we really saw, at least for chum salmon, a real change in their diet down to cnidarians, which are jellyfish. They have extremely low caloric content. That has been prominent in their diet 16, 17, 18, and especially 19. And so that change alone, you can see there's really some differences in the marine food web that had started in 2016, when these warming events started to occur here in the Bering Strait region. And it is, as you know, Gay and others, it is impacting the entire ecosystem in different ways, through reduced fitness of prey, and then reduced fitness of fish, and even, what was it, an unusual mortality event for ice seals. All these things seem to be tied together. So I hope everyone understands.
Seabirds are hungry.
Birds, oh yeah, seabird die-offs. I mean, it definitely. So I hope everybody understands that the work that we're doing with this survey, which is integrated ecosystem work, ties into what's going on with the bottom trawl survey. And Gay, you mentioned something, and how do we get to the predator point of this, and we can do that with, now that we have a bottom trawl survey up there. They're taking the diets of the gadids or the walleye pollock and the Pacific cod and others. So we can look at some of the forage interactions later on. These surveys are extremely important to continue to monitor how climate is impacting this system. And the survey in winter is going to be extremely important to look at what's going on in this in the Gulf of Alaska and the North Pacific Ocean, where things are really changing there too. And that's where your fish go. In the winter, they head off into the Gulf and down south of the ocean chain.
The salmon.
The salmon. Except the Chinook. Chinooks stay in the Bering Sea.
All right. Well, thank you, Ed. That's very helpful. One thing I guess I just want to point out to the audience is I've had this week already several phone calls and also several reports provided to me from down in the YK Delta to right here in our own neighborhood that people are having trouble catching tomcod. And that, I know we heard from Lyle Britt with NOAA Race Division last week that there was an 88% decline in the biomass of tomcod offshore. And then I think you also showed, Jim, that the little graph, the numbers went down pretty darn, if not the lowest. Are those the lowest numbers, or was there anything lower than what you showed on your slide? And I just wanted to give a shout out to our communities. If you're not able to catch, if you're seeing, I mean, we have to remain vigilant in the Bering Strait region, throughout the Bering Strait region, because we all understand that things are happening up here so quickly, and these nice people are trying to figure it out too. And it's all works much better if we're able to communicate what we're seeing and what they're finding as well. So if you're not seeing tomcod or any other fish that you're trying to find out, or any other thing that you're seeing with the dead seabirds and whatnot, please get in touch. You can call this office. You can call Brandon Amosic at Caloric. And my cell is, if you've got a pencil, is 434-1149. Sorry, Jim, I was blabbing away while you're looking up your slide on the saffron cod.
Well, no, I think our biggest change that we've seen was in the young saffron cod. We've seen those numbers really drop off, but we have seen a decline in the older ages of saffron cod. We've seen some low numbers in the past. Saffron cod, I think I mentioned, they're really kind of a difficult species to get a handle on, because they tend to occupy that really estuarine or brackish water. So it's really hard to get an idea of what their abundance is. So, one thing, even like for salmon, we saw everything was near shore. So it's from our surveys, it's difficult to tell for sure if they're just moving further inshore outside of the area where we could sample, or if they are possibly moving north. And that's kind of the concern, is that there could be shifts in the distribution of that species.
Right. I was so curious about the sea lion activity, and for those in the region know that on third week of October, mid-October, we had over 100 sea lions hauled out at Fairway Rock. So, and also St. Lawrence Island's having their pulse of sea lions as well. And we also were having humpbacks. Right as the ice was coming down, we're having this mix of ice and non-ice species. and they were foraging heavily in the Strait. And my question, I see Lyle Britt's on here too. If you had to take a stab at what you think they might be feeding on in there, that would bring humpbacks and stellar sea lions into the same area. I have some thoughts on that, but you guys know your fish. Do you think it's your cod, pollock, herring? Best guess? What's going on right now inside the Strait that's creating this unusual event? It's a guess. You're not held to it, but I'm just so curious. I mean, you said herring was the biggest one out there, right? The biggest biomass. Is that right?
Yeah, I mean, if you want to guess,
I do. I just want to guess.
I wouldn't be surprised if, I mean, typically in the past when we come up to an area where there's lots of whale activity in our survey, it's usually where there's concentrations of capelin. And sometimes you can pretty much tell when you're going to be catching a lot of capelin because there's lots of activity. And so I think in the bottom trawl survey, they were also seeing some capelin up in that Bering Strait region. That's kind of where we were seeing capelin on our survey. You know, I'm not sure if stellar sea lions feed on capelin, but I know
they want something chunkier typically.
Yeah.
That's what makes me curious, that they're both in there feeding very close to each other. But anyway, all right, thanks.
Yeah, it could be multiple species there.
And then, of course, last question that's for me, unless we have another one from the audience or the callers. Oh, we have a comment from Lyle Britt. With the formation of ice starting, that should, quote, push subarctic species south, so it could be multiple. Okay, thank you, Lyle. That's good. And it is, they're right up against the ice. Normally that would be happening to the south of us at this time of year. I mean, you know, yes, the ice will push those guys out. Thank you.
Yeah, so that makes sense. Probably more multiple species could be creating more of a hotspot of feeding activity in that area.
And then always the question, because if you live in the Bering Strait region, you know transboundary. Do we have any idea? Do you have a partner in the Russian waters in Chukotka or with the Russian Federation that you're able to pass along this information and maybe get a better understanding of how their fish are on their side of the border? Is there any hope on that?
Well, we have a number of partners with Russia in particular, with the North Pacific Anadromous Fish Commission, and
awesome.
So we all these surveys really started together with partnerships with Russia and Japan, and so the first 5 or 6 or 7 years of the survey, you know, we had fairly widespread coverage of the entire Bering Sea, but those international surveys have the international component to the surveys have not continued, but we do have partners in Russia that we can reach out to.
All right. Well, good luck with that, and I hope you're able to get lots of information as you're sharing our Bering Strait information. Hopefully, the Bering Strait from the west will be able to provide information. It just seems amazing that the Bering Strait is on their own, kind of on the U.S. side, anyway. So, thank you so much. Thank you to the audience. I think that's it for questions. So, thank you so much, Jim. That was really interesting, and a couple of announcements. So one thing is next Thursday, there is no Strait Science. There's a lot going on. Number one, know that if you're in the Nome region or if you're curious to see how we handle ourselves in the winter, there is the Nome Arts Council will have on their Facebook, because out here in the Bering Strait region, COVID's still going through the roof. So we've all gone virtual. They're having on Friday night at 7, Friday and Saturday night at 7 p.m. If you get on the Facebook page, they've got the open mic night. So people have been turning in their 5-minute recordings of whatever Nome does. And so they're also doing there'll be a silent auction. There'll be a fundraiser for an endowment for the Nome Arts Council. So if you want to get a peek at Nome, get on Facebook on 7 o'clock next Thursday. There's also a Port Commission meeting before that, so you're all welcome to come down to the council chambers for a Port Commission meeting, which nowadays the topics are pretty interesting. They're always interesting, but more so. And the next Strait Science will be the 2nd of December. Currently, we have Sekuliak is left Nome and is back up. They're at about 70 degrees, I think, today, and they're chunking out their work that they had in front of them. It is starting to ice up. They are in some gray ice right now. Not a problem for the ship, not a problem for the people on board. They're making good time, and they're getting a lot of work done from what I can hear. They are supposed to be back at the dock on the 17th of this month, next week. They, of course, what's happening, it looks like it's still too far out, but it looks like there may be weather, which might make it more interesting for all of us watching what they do next. However, they're supposed to come back on the 17th. On December 2nd, Seth Danielson and Jackie Grebmeyer, who are the leads of this particular effort, are going to give us an overview of what they found, what they saw, and some of the first results of their information from the Chukchi Sea this late in the year. So we're really looking forward to it. They're going to push themselves to get that done. And I encourage everyone to come to that one. It'll be really interesting to hear what they found in the Chukchi. With that, thank you all so much for coming.